Typhoon Chan-hom has just carved an unprecedented path across Japan's Ibaraki Prefecture. It is the first typhoon to hit that region since records began in 1951. At landfall, the storm carried 980 hectopascals of pressure, with winds of 90 kilometers per hour, snapping trees and tearing roofs across the Kanto region. It passed within 48 kilometers of Narita International Airport. It knocked out power to over 3,000 homes. And it injured 5 people as it tore across Honshu on a track so unusual that meteorologists are still studying it. But here's what makes this moment truly significant. Chan-hom was not alone. While this storm was crossing Japan, Super Typhoon Dolphin was simultaneously slamming into eastern China with 150 km/h winds, forcing over 1 million evacuations and canceling 1,300 flights in Shanghai alone. 2 other tropical cyclones were churning in the Pacific at the same time. 4 systems, 1 ocean, all active simultaneously. This is not a single storm story. Something significant is happening. Today we are going to break down exactly what happened when Chan-hom crossed Honshu, and why this storm is part of a much larger pattern of simultaneous escalation across the entire Pacific Basin. We'll look at the unprecedented track, the rare 4 cyclone outbreak, and what this means for a region still recovering. No guessing, no dramatizing. Just the facts, the science, and the real stakes. If you've ever been through a typhoon or hurricane, you know that moment when the wind changes. What did that feel like for you? Tell us in the comments. Subscribe now, because we're tracking every system in this Pacific outbreak, and the next update could affect millions more. The moment of landfall came around 8 in the evening local time on Tuesday. The center of Chan-hom crossed the coastline of Ibaraki Prefecture, a region that sits northeast of Tokyo, directly on the Pacific Ocean. For the people living in the coastal towns of Kitaibaraki and Hitachi, the evening began with a familiar sound. The wind started as a low hum. Then it grew into a constant roar that made conversation impossible. By the time the eye of the storm reached the shore, the rain was falling almost horizontally, driven by gusts that reached 126 kilometers per hour. That is highway speed. Imagine standing on the side of the expressway while cars pass at full speed. That is what the wind felt like. That is what it did to trees, to power lines, to roofs that had stood for decades. In Kuji, an Iwate Prefecture city in Tohoku, 121.5 millimeters of rain fell in just 12 hours. That is nearly 5 inches of water dumped on a single city in half a day. The drainage systems in these smaller towns were not designed for that kind of volume. Water pooled in intersections. It poured down hillsides and into basements. The rivers that run through these coastal valleys began to swell, and this was just the beginning. The storm was still moving. It had not even reached the mountains of central Honshu yet. The worst of the rain was still ahead. The Japan Meteorological Agency, known as the JMA, confirmed that Chan-hom was the first typhoon to make landfall in Ibaraki Prefecture since their records began in 1951. That is 75 years of tracking. 75 years of storms approaching Japan from every direction. And in all that time, no typhoon had ever taken this exact path into this exact region. The previous record for the closest approach was set decades ago, but even that storm stayed offshore. Chan-hom came all the way in. It crossed the beach, it moved inland, and it kept going, west across the rice paddies, over the mountains, and toward the opposite coast. To understand what this means, you have to understand the numbers. At landfall, Chan-hom had a central pressure of 980 hectopascals. Hectopascals measure atmospheric pressure, and lower numbers mean stronger storms. Normal sea level pressure sits at about 1,013 hectopascals. Chan-hom was 33 units lower. That might sound small, but in meteorology, that difference represents a massive amount of energy. The maximum sustained wind speed at landfall was 90 kilometers per hour. Sustained wind means the average speed over a full minute, not just a single gust. It is the consistent force that pushes against everything in its path. And at 90 kilometers per hour, that force is enough to snap mature trees at the trunk, tear roofing tiles from their mounts, and turn loose objects into projectiles. The maximum instantaneous gust recorded was 126 kilometers per hour. That is the kind of wind that lifts cars off their suspension and throws debris through windows. In Ishinomaki, a city in Miyagi Prefecture, the maximum gust hit 85 kilometers per hour. In Kitaibaraki, it hit 71 kilometers per hour. These are not theoretical numbers. These are measurements taken from weather stations that were standing in the middle of the storm. The human impact was immediate. More than 3,000 homes lost power across Ibaraki and Tochigi prefectures. In the darkness, residents could hear the wind tearing at their walls. 5 people were injured, 2 men in Iwate Prefecture, 3 women in Ibaraki. None of the injuries were life-threatening, but each one represents a moment of danger. A falling branch, a shattered window, a slip on a wet stairway. These are the small catastrophes that happen inside a larger one. The storm also disrupted travel in ways that rippled far beyond the immediate landfall zone. Chan-hom passed within 48 kilometers of Narita International Airport. That is about 30 miles. For context, Narita handles over 40 million passengers every year. It is one of the busiest airports in Asia. At 48 kilometers away, the storm was close enough to shut down flight operations entirely. The wind and rain made landing unsafe. The airport grounded flights and diverted incoming aircraft to other cities. The storm also forced JR East, one of Japan's largest railway operators, to suspend services on multiple lines. The Joban line, which connects Tokyo to the northeastern coast, was shut down completely. The Sobu Main Line, the Uchibo Line, the Kashima Line, the Kururi Line, the Sotobo Line, the Togane Line, and the Narita Line all experienced delays or full suspensions. For commuters, this meant hours of waiting. For travelers trying to reach the airport, it meant missed flights and rebooked itineraries. The disruption spread through the entire region like ripples in a pond. One storm, one coastline, thousands of disrupted lives. Bloomberg reported that Japanese airlines halted flights as Chan-hom neared Tokyo. ANA's canceled routes included services linking Haneda with Fukuoka and Hiroshima, and Narita with Sapporo and Osaka. These are not small regional routes. These are major domestic arteries that connect the capital to the rest of the country. When these routes shut down, the entire national transportation network feels the pressure. Passengers scrambled to find alternative routes. Hotels near the airports filled up within hours, and for international travelers who had planned their trips around Oban, the storm turned a cultural experience into a logistics nightmare. But what made this landfall truly historic wasn't just where it happened, it was how the storm moved once it crossed the coast. Most typhoons that hit Japan approach from the south or the southwest. They travel northward, pushed by the prevailing winds and the rotation of the earth. They come up from the Philippines or the waters near Taiwan, and they sweep across the southern islands before curving toward the northeast. That is the normal path. That is what forecasters expect. That is what emergency planners prepare for. Chan-hom did none of that. Chan-hom approached from the east. It came across the open Pacific Ocean, moving directly westward toward the coast of Ibaraki. And after it made landfall, it continued moving west across Honshu, the main island of Japan. This is the wrong direction. This is the opposite of what typhoons are supposed to do, and it has meteorologists asking serious questions about what changed in the atmosphere to make this happen. The answer lies in a massive blocking high-pressure system sitting north of Japan. A blocking high is a large stationary area of high pressure that acts like a wall in the atmosphere. It does not move, it does not weaken. It sits in one place and redirects everything that comes near it. In this case, the high pressure system sat over the Sea of Okhotsk in northern Japan. It pushed Chan-hom westward, steering the storm across Honshu instead of allowing it to curve northward, as typhoons typically do. This is not a small deviation. This is a fundamental change in the storm's trajectory. The result was that the greater Tokyo metropolitan area, home to more than 37 million people, was directly in the storm's path. That is one of the largest urban concentrations on Earth, and it was facing a typhoon coming from a direction that had never been recorded in 75 years of tracking. The timing made everything worse. This week is Obon, one of Japan's 3 major holiday periods. Obon is a Buddhist festival that honors the spirits of ancestors. It is a time when families travel back to their hometowns to visit graves and gather with relatives. Millions of people are on the move, trains are packed, highways are congested, airports are running at full capacity. The storm hit exactly when the country was at its most mobile. The Japan Meteorological Agency issued warnings for the Kanto region, which includes Tokyo, and urged people to avoid non-essential travel. But for many, the travel was not optional. They had already booked their tickets. They had already taken their vacation days. They had already promised their families they would be home. So they traveled anyway. They traveled into the path of a storm that had no precedent. The storm brought heavy rain to the Kanto Koshin region. Forecasters predicted up to 180 millimeters of rain in 24 hours. That is over 7 inches. In a region where the ground is already saturated from previous rainfall, that much water creates a serious flash flooding risk. Rivers can rise suddenly. Urban drainage systems can overflow. Low-lying areas can flood within minutes. In the Tohoku region, forecasters predicted 150 millimeters of rain, with an increased risk of landslides on slopes that have already absorbed weeks of moisture. The ground becomes unstable. The soil loses its grip on the bedrock. And when enough rain falls, entire sections of hillside can give way, carrying trees, rocks, and debris down into the valleys below. The Tokai region, which includes the city of Nagoya, was forecast to receive 120 millimeters. Every region in the storm's path faced the same question: how much water can the ground absorb before it fails? While Japan was bracing for Chan-hom, another monster was simultaneously bearing down on a different coast. Super Typhoon Dolphin was approaching eastern China with a fury that dwarfed anything Chan-hom could produce. Dolphin had reached Category 5 strength over open water, with sustained winds of 205 kilometers per hour. That is 125 miles per hour. That is the kind of wind that flattens buildings. It had a minimum central pressure of 896 hectopascals, a number so low that it represents one of the most intense storms on record for that part of the Pacific. To understand what 896 hectopascals means, consider that a standard hurricane is around 980. A major hurricane is around 950. Dolphin was operating at a level that scientists describe as almost off the charts, and it had been doing this for an extraordinarily long time. Dolphin traveled more than 6,000 kilometers before making landfall. That is 3,728 miles. An ordinary typhoon might travel 2,000 kilometers before weakening or making landfall. Dolphin traveled 3 times that distance. It crossed the entire western Pacific, gathering energy from the warm ocean water, strengthening over days and weeks. It was not a sudden storm. It was a marathon runner that had been building endurance for its entire journey. By the time it reached the coast of eastern China, it had weakened from its peak intensity, but it was still a major storm. Dolphin made landfall near Yuhuan in Taizhou City, Zhejiang Province, at around 5:30 in the evening on Sunday, August 9th. The city of Wenzhou, just south of the landfall point, had already relocated more than 900,000 residents. Shanghai, further up the coast, evacuated at least 30,300 people. More than 1,000 emergency shelters were opened across Zhejiang Province alone. The scale of the response was staggering. This was not a local emergency. This was a national mobilization. At landfall, Dolphin had sustained winds of 150 kilometers per hour. That is 93 miles per hour. That is a Category 1 equivalent hurricane, still strong enough to cause catastrophic damage. The Chinese government responded with one of the largest evacuations in recent memory. More than 1 million people were moved out of the storm's path. In Shanghai alone, 1,300 flights were canceled. That represents 60% of all scheduled flights at Hongqiao and Pudong airports. Imagine showing up to the airport and finding that 6 out of every 10 flights have been grounded. Imagine trying to rebook a flight when every other passenger is trying to do the same thing. The airports were chaos. The city of Shanghai, home to more than 26 million people, came to a near standstill. Streets that are normally packed with commuters were empty. Businesses closed their doors early. Construction cranes were locked in place. The Huangpu River, which runs through the heart of the financial district, surged with rainwater. Flood barriers that line the waterfront were tested to their limits. Emergency crews positioned boats in low-lying neighborhoods in case the water rose high enough to trap residents. The entire eastern seaboard of China was bracing for the worst. The highways were jammed with evacuees. The train stations were packed with people trying to get to higher ground. Forecasters predicted 250 to 500 millimeters of rain in Zhejiang Province. That is up to 20 inches in a single event. That is enough water to submerge entire neighborhoods. That is enough water to turn streets into rivers and rivers into lakes. Here is the stark reality of the situation. 2 storms, 2 countries, 1 moment in time. Chan-hom hit Japan with 90 km per hour winds. Dolphin hit China with 150 km per hour winds. Chan-hom knocked out power to 3,000 homes. Dolphin forced over 1 million people from their homes. Chan-hom injured 5 people. Dolphin's death toll is still being counted. And while both of these storms were making landfall, 2 other tropical cyclones were churning in the Pacific. Peilu was active near Guam, the island territory that hosts a major U.S. military base. Tropical Cyclone 15W was active near Wake Island, a remote atoll in the middle of the Pacific. 4 systems, 1 ocean, all active simultaneously on August 9th. To understand what this moment means, we have to zoom out, way out, to see the entire Pacific Basin. A satellite image taken on August 9th shows the Western Pacific covered in spinning systems. 4 separate storms, each with its own circulation, its own path, its own potential for destruction. This is not normal. This is not something that happens every year. This is a rare event that meteorologists are still trying to understand. The Pacific Disaster Center, which monitors hazards across the region, flagged the simultaneous activity as a notable multi-system event. Yale Climate Connections, a respected climate research organization, called Dolphin historic. These are not exaggerations. These are assessments from institutions that track storms for a living. The historical context makes this even more striking. In 2019, Typhoon Faxai struck Chiba Prefecture in Japan with sustained winds of 207 kilometers per hour. That storm knocked out power to 930,000 homes. Nearly 1 million households sat in darkness, some for weeks. In 2024, Typhoon Shanshan killed 6 people and injured dozens more in southwestern Japan. These storms are not ancient history. They are recent events. They are the standard against which Chan-hom must be measured. Dolphin itself set records before it even reached China. It became the strongest typhoon on record to develop so close to the international date line. It was the planet's 5th Category 5 tropical cyclone of 2026, putting this year ahead of the pace from the all-time record of 1997 when 12 Category 5 storms occurred globally. The Pacific is running hotter and producing stronger storms than at any point in modern tracking history. And Chan-hom, despite its unprecedented track, caused far less damage than either of those storms. The reason is simple. Chan-hom was weaker, it had less energy, it moved faster, and Japan was prepared. The Japan Meteorological Agency had been tracking Chan-hom for days. They knew it was coming. They knew the track was unusual. They issued warnings early and updated them constantly. Local governments activated their emergency response systems. Schools closed. Businesses sent employees home. Residents in coastal areas moved to higher ground. The preparation worked. The power outages were limited to 3,000 homes, not 930,000. The injuries were 5, not dozens. The damage was significant, but it was not catastrophic. This is what preparation looks like. This is what early warning systems are designed to achieve, and this is the difference between a disaster and a disruption. But the storm is not over yet. The Japan Meteorological Agency forecasts that Chan-hom will weaken to a tropical depression by Wednesday afternoon. A tropical depression is the weakest classification for a tropical system with sustained winds below 63 kilometers per hour. The central pressure is expected to rise to 996 to 998 hectopascals, which means the storm is filling in and losing its intensity. But the rain is still falling. The ground is still saturated. The rivers are still running high. The risk of flooding and landslides remains. The storm is dissipating now, but the questions it leaves behind are just beginning. What does it mean when a typhoon takes a path that has never been recorded? What does it mean when 4 tropical cyclones are active at the same time? What does it mean for a region that is already dealing with the effects of climate change, rising sea levels, and warming ocean temperatures? Scientists do not yet know whether this specific event is directly caused by climate change. But they do know that warmer oceans provide more energy for storms. They do know that the Western Pacific has been experiencing record sea surface temperatures. They do know that the conditions that made this outbreak possible are becoming more common. The science is not settled on every detail, but the trend is clear, the pattern is visible, and the stakes are rising. Right now, as Chan-hom weakens over western Japan, the Sea of Japan is absorbing the remnants of a storm that should never have taken this path. The warm water that fueled its approach is still there. The blocking high-pressure pattern that steered it westward is still in place. And the conditions that allowed 4 cyclones to spin simultaneously across the Pacific have not changed. The season is far from over. August and September are historically the most active months for Western Pacific typhoons. What happened this week may be a preview, not an anomaly. When the satellite images came together on August 9th, the Western Pacific looked like a pressure cooker, 4 tropical cyclones spinning simultaneously from Guam to Japan to China, 2 of them making landfall within hours of each other in 2 different countries. Chan-hom hit Japan as a tropical storm that broke a 75-year record. Dolphin hit China as a super typhoon that had traveled 6,000 kilometers and forced over 1 million people from their homes. One storm weakened before landfall, the other arrived at full fury. But in both cases, the human cost was far lower than it could have been. Japan lost power to 3,000 homes, not 930,000 like when Typhoon Faxai struck in 2019. China evacuated 1 million people, and the death toll remained remarkably low. This is not luck. This is preparation. The difference between disaster and disruption is what happens before the storm arrives. Early warnings, evacuation orders, infrastructure built to withstand the worst. Japan and China both knew what was coming. They acted, and lives were saved. The question now is what happens next? Chan-hom is dissipating over the Sea of Japan, but Pelu is still churning near Guam. Tropical Cyclone 15W is still active near Wake Island. The Pacific is not done. Have you ever been through an evacuation or a major storm? What did your community do right or wrong? Tell us in the comments. We read every single one. Subscribe to Earth Dispatch because we're tracking every remaining system in this Pacific outbreak. The next update could affect millions more. And if you know someone living in the Pacific region, share this video with them. Knowledge is preparation.